Good morning, everyone. So we are going to start this third class of redox reaction. Okay. So today we will be studying more about balancing ion electron method as well as oxidation method. Then we will continue the concept of equivalence, right? So the concept of equivalence is same as mole concept, means you can solve a problem of stoichiometry, right? Again, problem of stoichiometry from either mole concept or equivalence concept. So they're parallel concepts, right? Means suppose we have a problem. So that problem can be solved by either mole concept or equivalent concept. Okay, got it, right? So we will study that concept also. But before that, let's see what we have studied it till last class, right? Okay. Okay, guys. So let's have a recall test. So the number of moles of solute per unit volume of solution is called, tell me. We have already studied this. Yes, very good. B, molarity, right? Second one, the number of gram equivalent. The number of gram equivalent of a solute, right, per unit of volume of solution is, why I'm asking this, because you have already covered this chapter in school, right? Yes, very good everyone. Normality, very good. So second is normality, very good everyone. So I guess you guys remember basic terminologies, very good. Third one, for an acid, normality is related to molarity, right? By which of the following, tell me. See, for acid, it is opposite, right? Okay, okay, I'm getting many answers. I'm getting A as well as C. One student D. Okay, we will see. Fourth one, identify the unbalanced reaction. Identify the unbalanced reaction. Fourth one. Fourth one is pretty easy, right? Yes, very good. B. Fifth one, 1 gram of hydrogen can displace dash gram of oxygen. Fifth one. Think about it, guys. Think about it. Okay, I'm getting 3 answers. I'm getting 2, 6 as well as 8. Let's see. Let's see. So the answer is 8, B, C, and A, right? Fifth, D. It is D. Okay, that's the basic definition. Okay, that's the basic definition, right? So this was the basic. I was just trying to know how much you know, how much you remember, because this chapter have already been covered in your school. Okay, okay, right? Okay, so we will start with, we will continue the balancing, right? We will continue the balancing. Okay, so balancing, we will continue balancing, guys. So I hope all of you went through the PDF, yes or no, right? Yes. Okay, Pranjal is having a doubt. Okay, oxidation state of Ko2. See, the Ko2. Ko2 is your which oxide? Tell me. Ko2. It's potassium peroxide, right? The potassium is +1 always. Okay, right? Potassium is +1 always. Potassium cannot be, yes, potassium cannot have any other oxidation number. So when you talk about Ko2, yeah, when we talk about Ko2, K is +1 always, right? So O2 will be what? O2 should be -1. So this is your superoxide, right? This is your superoxide because O will have charge of -half. That we have already studied, na? Right? Not peroxide, sorry, superoxide. O2 -1 charge is there, right? Okay, it's superoxide. because the charge, yes, the charge is -1. Okay. See, structure, it is an ionic compound. Okay, Pranjal, it is an ionic compound. K plus O2 minus. Okay. Okay. So let's continue. Let's continue with our balancing. Okay. So first we will be covering balancing. Then we will talk about normality and equivalence. Okay, guys. Right. In module, equivalent concept is discussed first, then balancing, but we will try to do balancing first, then equivalent concept. Okay, right? Okay, so see, wait, yeah. So in last class, we studied how to balance a reaction, right? So basically we have two methods. Okay, basically we have two methods. The first method is oxidation number method and second is ion electron method, right? So obviously there will be some steps and all those things, but I want you to focus only on the examples, because if you understand the example, right? If you understand the example, it is easier to remember, okay? Now, when you talk about balancing, right, let's start with one example. Okay, I'll just take the same example from your, yeah, I'll just take the same example which I have given in the PDF. Okay, just give me a minute. Yeah, so let's take one example which was given in the PDF that I have sent, right? So the example is this. The example is this, right? Let's start with this example. We have FeSO4, okay, FeSO4 plus KMnO4 plus H2SO4 gives Fe2SO4 whole thrice plus MnSO4 plus K2SO4 plus H2O. Okay, so I guess this is quite big reaction, right? An unbalanced one. Yes or no, right everyone? Yes? Okay, so we have to balance this. Tell me yes or no, we have to balance this. Now, I'm not telling you which method it is, right? Because I want you to be intuitive. I want you to be intuitive, right? Okay. Okay. Just think about this. Just think about this. First of all, what should be the first step? Step one, right? Find the oxidation number of each component. Find oxidation number of each component, right? Each element. Got it, everyone? Right? Okay. So if you see the charge, right? Oxidation number of each component, each element. So here Fe is having +2, +2. Now SO4, so SO4 is not changing at all, right? So SO4 is not changing. SO4 here, SO4 here, SO4 here. So overall SO4 have -2. Okay. S will have how much? +6, right? So I'm not going into that, right? You can just do that also. K will have +1 here, right? Mn will have plus, tell me, 7 over here, right everyone? +7. Oxygen -2 as always, right? Again here we have H as +1. SO4 whole charge is -2. Okay. Now if you see here, Fe2SO4 whole thrice, Fe2SO4 whole thrice, then you can say that here the charge of Fe is +3, right everyone? Because see, Fe to SO4 whole thrice, so charge is +3, and on SO4 it is -2 only. Now when you talk about MnSO4, it is +2. Okay, SO4 -2, K2SO4 again +1 -2, H2O +1 -2. Easy? Tell me, step 1 easy? Guys, tell me step 1. Everyone got step 1? Raise your hand. Okay, very good. Now, what was the second step? Tell me, second step. I'll just do it. I won't write the steps. I'll just do it, right? Second step. Can you find out of these, right, which is your oxidation reaction, which is a reduction reaction? For example, Fe 2 plus, right? Or just remove the spectator ions. Remove the spectator ions, guys. Remove the spectator ions. So what do you think? Which is your spectator ion? SO4 2 minus is your spectator ion, yes or no? SO4 2 minus is your spectator ion, right? K plus is your spectator ion. Just write, yes, just write the component whose charge is changing, as simple as that, right? So I can just say that we will have Fe2 plus MnO4 minus gives Fe3 plus Mn2 plus, right? Now, I told you already that whenever we have oxides like MnO4, Cr2O7, right? Write O with them, okay? Write O with them, okay? You should not write Mn7 plus, you should write MnO4 only, okay? So this is your basic redox reaction. This is your redox reaction. Because everything else is your spectator ion, yes or no? Everything else is your spectator ion. The charge is changing, right? Is charge is changing on H2O? No, na. Hydrogen is +1 only, oxygen is -2 only. So what I have told you in the last class about spectator ions. Spectator ions are the ions in which the oxidation number does not change, right? So the oxidation number is changing for these elements only, right? Okay, so this is your, tell me, this is your normal, this is called a skeletal equation, right? Okay, or normal equation, and this is your redox reaction. Okay, now if you see this, the next is write down the oxidation reduction reaction, right, separately. So Fe2 plus will give Fe3 plus electron, right everyone? This is your oxidation reaction or reduction reaction. This is your oxidation, yes. And next step, right, MnO4 minus, so it is +7 and converting into +2. So how many electrons should be added? 5 electrons should be added to give, tell me what? Mn2 plus. This is your reduction. Everyone is getting till this step, guys? Tell me. Everyone is getting till this step? Anyone have any issue till this step? Anyone have any issue till this step? If anyone have any issues, please let me know. Anjali, Sumaya is present. Smriti. Sumaya is absent. Krishna, you got it or you didn't get it? Anyone who is Sumaya's friend? Please message her. Okay, very good. So I guess everyone got this. Preetham, are you getting? Smriti, just ask Sumaya to message me. Okay. Right now, what do you think? What did you think? What was the next step? What was the next step, guys? What we should do? Just think about it intuitively. Don't remember any step. Yeah, guys, sorry, I got a call. That's why I was disconnected, right? Okay, so yes, Akshay, very good, right? Very good. So first thing that we should do is see the electrons, right? Very good. You see the electrons. Yes, Abhiram? So when you talk about the electrons, here one electron is lost and here 5 electron is added. So you have to multiply this reaction by 5. Okay, this reaction by 5. Now second thing that we should do, right, after electron is balanced, second thing that we have to do, oxygen, right? We have to balance oxygen. So when we talk about first reaction, oxidation reaction, no oxygen is there, no oxygen, right? But here oxygen is there, so we need to balance. Now tell me, this is your acidic reaction or basic reaction? This is an acidic medium or basic medium? What can you say? Acidic, very good, right? So whenever we have acidic, yes. So what we will do, what we have studied, so what we can do is MnO4 minus. So this oxygen is in reactant side, right? So we have to balance this. So what we have to do, we have to add H2O. H2O, how many H2O? 4 oxygen. So we should add 4 H2O. Okay. Now oxygen is balanced, but what about hydrogen? We have 8 hydrogen here. So since it's an acidic medium, we will just add 8H plus. As simple as that. Got it? Tell me, got this? Yes or no? Yes or no, guys? Nishita, I just said after balancing the electrons, we will balance the oxygen. So in oxidation reaction, right, we don't have oxygen, so we need not to balance. But when you talk about reduction reaction, we have 4 oxygen in reactant side. So I should have 4 oxygen on product side also, right? So in order to have oxygen on product side, we will add 4 H2O, right? Okay, but we will get extra 8 hydrogens, so I will add 8H plus on the reacting side because it's an acidic medium, so I can add H plus. Okay, right? Tell me, right? So now if you see, we have a balanced redox reaction. Write down the balanced redox reaction now. So it will be what? Add them, add this is A and this is B. Add A and B, add A and B. So we will get what? 5 Fe2 plus, right, plus 8H plus MnO4 minus. Now electron, 5 electron will get cancelled, right? So I will not write electron. So it will give 5 Fe3 plus Mn2 plus 4H2O. Got it, everyone? Tell me till this point. Okay. Jitendra, please see the question clearly. We never had Mn2O4. We had only MnO4. Okay. Okay, got it. Got it, Smriti? See the electron, Chulika, see the electron, right? In oxidation reaction, how many electron is lost? Tell me. In oxidation reaction, how many electron is lost? Only one, right? But in reduction reaction, 5 electron is added, right? So obviously, if you're giving only 1 electron and there's someone who is taking 5 electron, how is it possible? Got it? Got it? Okay, very good. So this is your balanced redox reaction. I've given you enough time. This is the balanced redox reaction. Now, if you see the reaction here, I balanced this redox reaction, right? And I had removed all the spectator ions. So what we should do now? We should add all the spectator ions as it is. Yes, yes, everyone. So let's add all the spectator ions. So Fe2 plus, Fe2 plus was with FeSO4. So it should be 5 FeSO4 plus H plus was with H2SO4, right? So tell me, if I have 8 H plus, how many H2SO4 should I have? Tell me. If I'm having 8 H plus, how many H2SO4 should I have? 4. Yes, right? Very good, Ronak. So 4 H2SO4, very good. Plus MnO4 minus, see MnO4 minus was with K. So it is just KMnO4. So this is reactant side. Now see the product side. See the product side, everyone. Okay, Fe3 plus. Fe3 plus was with what? Fe2SO4 whole thrice. Think about it. Fe2SO4 whole thrice means one molecule of Fe2SO4 whole thrice give 2 Fe2 plus, right? And here I'm having 5 Fe3 plus. So what it should be? It should be 5 by 2 Fe2SO4 whole thrice. Yes or no, guys? Tell me. Yes or no? Because this will give you 5 Fe3 plus, right? Got it, everyone? Why it is 5 by 2? Because one molecule of Fe2SO4 whole thrice will give 2 molecule of Fe3 plus. Okay, that's why it is 5 by 2. Ultimately, you should get only 5 Fe3 plus. Okay, very good. Plus. Now Mn2 plus. Mn2 plus was Mn, tell me, MnSO4, right? MnSO4, right? MnSO4. MnSO4 plus H2O, right? H2, for H2O. Now, something is missing, right, everyone? Something is missing, yes or no? Right? What is missing? K, yes, very good. K is missing. And here we have only 1 K, right? Here we have only 1 K. So here we should have half K2SO4, right? Half K2SO4, because we should only have spectator ion. Got it, everyone? Tell me yes or no? Yes or no? Anyone have any doubt till this point? Clear? Right? So this is your balanced reaction, right? But it doesn't look good when we have half in the denominator. So what we should do? What we should do? Tell me. Either you can leave this. This is also correct, right? But it doesn't look good when we have half in the, yes, denominator. So we should multiply by 2. So if you multiply by 2, if you multiply whole reaction, every reaction by 2, what we should get? 10 FeSO4 plus 8 H2SO4 plus 2 KMnO4 gives 5, this is 5, okay? Fe2SO4 whole thrice plus 2 MnSO4 plus 8 H2O plus K2SO4. Got it, everyone? Everyone got this? Right? Right, everyone? Now think about this, because see, when I was a student, I was literally very confused which step to follow first, which step to follow second, what is oxidation method, what is reduction method, right? Okay. Because it is half K2SO4, right? So obviously if half is multiplied by 1, we will get 1 only, na? Got it? Now, think about this. Do you have to remember any steps in this? Or most of the steps are intuitive? Yes, because I haven't told you which method it is. Okay, right? Because Yeah, because see, when you have to solve a problem, you don't have to worry that which method it is. You just have to solve it. And both ion electron method and oxidation method, 70% is same, 70% is same, or 80% is same, right? So it creates kind of confusion in students, okay, right? Okay, so I hope all of you understood this, right? First try to balance, then we will see what are, yes, what are the two different methods. Okay, so for information, this is called your ion electron method. This is your ion electron method, and I prefer this method, right? Oxidation reduction method, okay, right? Oxidation of a method is same till, yeah, same till few steps, okay, right? So we'll see one example of that also, but you should remember, or you should know one method, right, thoroughly. Okay, so let's solve one more problem. Okay, guys, let's solve one more problem. K2SO4, okay, not K2SO4. K2Cr2O7. So those who have gone through the PDF, I hope they are understanding this in a better way, right? K2SO4 plus H2SO4 plus FeSO4 gives Fe2SO4 whole thrice. It's almost same reaction, plus K2SO4 plus Cr2SO4 whole thrice plus H2O. Now try to balance this, guys. No, Srihari, see, we are normally, right? In school, you just have to balance. In school, in 11th, it might be asked, but obviously when you talk about JEE or NEET, how does it matter? Okay, how does it matter, right? And see, both methods have its pros and cons, right? So we will see both and you decide which method you have to follow, okay, right? To me, this feels more intuitive, right? Okay, that's why I remember this only, like I prefer this. Okay, some of you might prefer oxidation number method. Okay, so it doesn't matter, right? We will study both. Okay, try to solve this one first, guys. Try to solve this one first, step by step. Okay, so I hope most of you are solving this. So first I will just remove spectator ions, right? So after removing spectator ions, I'll be left with, I hope all of you remember, we have solved this already in last class. Okay. This is your final redox reaction after removing all the spectator ions, right? This is the final redox reaction after removing spectator ions, right? Because SO4, 2 minus, K plus, H plus is all are spectator ions. Got it? Tell me yes or no, right? Now, if you see this, Cr2O7, 2 minus. Very good, Akshay, Abhiram, correct, both of you. Okay, so if you see this, right, if you see this, so the charge here is what? +6 on one chromium, +6 on one chromium. Okay, right? Ronak, you have multiplied by, Ronak, there's some error. Okay, so that it's correct for you. Okay, so see, Cr2O7 plus 6 for 1. Now this is converting into 2 Cr3 plus, because obviously 2, right? That's why I have to take 2. So if you see how many electrons are changed, plus 6 to plus 3. Okay, so 3 electrons is gained by 1 chromium. Here we have 2 chromium. So we will have 6 electron gained. Yes or no? Tell me. 6 electron gained by Cr6 plus. Agree? Tell me, agree? Yes or no, guys? Tell me. This step, yes or no? Right? In the same way, Fe2 plus, right, will be Fe3 plus 1 electron. So obviously this should be multiplied by 6. Okay? And this oxygen, right? So we should have plus how many oxygen? 7 oxygen, 7 H2O. And this side 14H plus. As simple as that, right? As simple as that. See how easy it is, right? Now just add them. Add them. Okay? Add them. Right? So it is Cr2O7 2 minus plus 14H plus 6 Fe2 plus gives 2 Cr3 plus 7 H2O plus 6 Fe3 plus. Got it? Tell me yes or no. Guys, got this? Yes, Namika, very good, correct. You multiply by half. Okay, now this is a balanced redox reaction. Then what we have to do? Spectator ions, right? Spectator ions. Now add spectator ions. So this is what? K2Cr2O7. So K2Cr2O7 plus this is what? H2SO4. 14. So it should be 7 H2SO4 plus Fe. Fe is SO4. So it is 6 FeSO4 gives now 2 Cr, and this is Cr2SO4 whole thrice. So it is basically Cr2SO4 whole thrice plus 7H2O plus Fe3 plus. Now it is Fe2SO4 whole thrice. So 3 mole of Fe2SO4 whole thrice will give 6 mole of Fe3 plus. So it is 3 Fe2SO4 whole thrice plus. Now we are left with what? Potassium. So K2, right? Cr2O7, and here it is just K2SO4. So just K2SO4. As simple as that. Got it? So this is a balanced reaction, guys. This is a balanced reaction. Please check. Everyone, please check. K2Cr2O7 plus 7H2O plus 6 FeSO4 gives 3 Fe2SO4 whole thrice plus Cr2O4 whole thrice plus 7H2O plus K2SO4. That's it. That's it. Okay. Try to understand this. How many of you understood this? Just raise your hand. How many of you understood this? Just raise your hand. If anyone have any difficulty in the understanding, please ask. Okay. Okay, guys. So I hope all of you understood this ion and electron method. This was your ion electron method. Okay. This was your ion electron method. Okay. So I can say this was your ion electron method. Right? Right, everyone? So anyone have any doubt in ion electron method? Step, you have to remember only 3 steps. Okay. Now let's see oxidation number method. So why I taught you ion electron method first? Because both are same. There's only one difference. The difference is in oxidation number method, we will do 2-3 steps simultaneously. For example, right? Let's see, we have a problem like this. I'm just writing the skeletal equation, right? The redox reaction one. Okay. So MnO4 minus plus Fe2 plus. So we have already solved this. Okay, we have already solved this. So that's why you will get the idea what is the difference. Okay, right? Plus H2O. You just remove H2, it's fine. We will add it. Okay. So this was the reaction. Okay, this is also you have to balance now. Okay, right? So now what we have to do in oxidation ion electron method. So this is first step and second step, same as ion electron method. Okay, same as ion electron method. The only difference is, check here. We have plus 7 to plus 2 and plus 3 to, sorry, plus 2 to plus 3. Okay, right? So I can say that here, right? 1 electron is added plus 1 electron, right? Sorry, removed. My bad. 1 electron is removed. So minus 1 electron. Minus 1 electron. And here, see the arrow, right? See the arrow. Here, plus 5 electrons. Okay? So what we have to do, we have to balance the oxidation number. Okay, we have to balance the oxidation number. So what we have to do, we have to multiply this by 5 into 5, right? Okay, so this will become what? It will become MnO4 minus plus 5 Fe2 plus gives Mn2 plus 5 Fe3 plus. Now, if you see, you will say, sir, isn't it the same thing? It's just you are doing in one reaction instead of having two different reactions. So I'll say, yes, it is same, right? That's why I told you both almost same. Now, next is oxygen, same as what we did in ion electron method. 4 oxygen plus 4 H2O, 8 hydrogen, 8 H plus. That's it. Done. This is your balanced reaction. Balanced. Okay, got it? Tell me, got it? So don't you think that both are almost same? It's just that in this is your oxidation reaction method. Okay, so wait, I'll just write. Most of you might have confused. This earlier was ion electron method, and this is oxidation number method. Okay, Sneha, I will give you one more example. I'll explain, right, once more, don't worry, right? So let's see another reaction that we have already seen, okay? So let's see with the reaction that we have already seen, right? Oxidation method. Okay, so the reaction, right? The reaction is this. MnO4 2 minus plus C2O4 2 minus gives Mn2 plus CO2 in acidic medium. Okay, right? Okay, yes, that's what I said, right? See, in oxidation method, we are just adding up 2 steps, okay, right? Because in ion electron method, we used to write reduction reaction, oxidation reaction differently, then used to add, right? So that gave you better clarity that what is happening, okay? But if you understood that really well, you can just do it at once, right? For example, here Mn is plus 7, right? And C is plus 3. We have already solved this by ion electron method, and it is plus 2 and this is plus 4. So you can say that here carbon C, right? C is changing from +3 to +4, which is -1 electron. Okay. Okay. But there's one more difference, that here we have C2, here we have C2, right? So it should have 2 CO2, as simple as that, right? Just, yes, just balance the this electrons, right? This 2, okay, right? So one carbon is exchanging 1 electron. So 2 carbon will exchange how many electrons? 2. Got it? Tell me, yes or no? Yes or no? Okay. Now let's see this Mn. This Mn is gaining 5 electron, plus 5 electron, plus 5 electron. Now what do you think? What do you think? What should happen? Total electron is the LCM of this and this. So this should be multiplied by 5 and this should be multiplied by 2. Agree? Agree? This is what we did in third step of ion electron method. Step by step, guys. This is exactly the same thing that we did in third step of ion electron method. Okay. Yes or no? Tell me yes or no. Right? So we will get what? We'll get 2 MnO4 2 minus plus. Now you don't have to multiply this by 2 because it is already 2. Wait, I'll just remove 2 from here because it is already 2, right? Okay, we just have to multiply by 5 now. 5, right? Because it is 2 electrons. C2O4 2 minus gives 2 Mn2 plus it is 10 because it is 2 already, 10 CO2. Okay, got it? Mn oxidation number will be plus, okay, plus 7. Sorry, my bad. Yeah, my bad. It's MnO4 now plus 6. Okay, so it is 4 electron. My bad, guys. Right, sorry. So it is my bad. So this is plus 6, right? It's plus 6 to plus 2. So 4 electrons. Losing 4 electrons. So this should be into 2. Okay, my bad. So yeah, so now it need not to be multiplied by anything, right? Now it need not to be multiplied by anything. Okay, because I've given you Mn4 2 minus. Okay, so it will be what? It will be 1 only. It will be 2. This will be 1 only, and this will be 2 was already there, into 2 4. Right? As simple as that. Okay. Now, next is if it is acidic medium, see the oxygen in reactant side 4 and 8. Oxygen is 4, 8, 12, and here we have 8 only. So plus 4 H2O. Okay, balance oxygen. Then 8 H plus. Got it? This is a balanced reaction. Got it, everyone? Tell me, everyone, did you get this? Tell me, everyone, did you get this? This is for acidic. This is for acidic. Okay. Now, you should ask, so what if we have a basic reaction? Suppose instead of acidic, if it would have been basic, then what you have to do? Everything would be same, right? So I'll just write what you will do in basic. Now think about it. Can you add H plus? Can you add H plus in case of basic medium? Think about it. Yes or no? H plus in case of basic medium. What is a base? Which gives OH minus, right? So how can you add H plus in case of basic medium? You should add OH minus now. Suppose this is the reaction, right? I'm just taking this reaction only. MnO4 2 minus plus 2CO2. Sorry, 2C2O4 2 minus gives Mn2 plus 4CO2. Now this is in basic medium. What we have to do, instead of H plus on the left hand side, you can add OH minus. Reactant side, you can add OH minus. Okay, got it? Now, what is the difference here? So just think about it. Suppose we are lagging 4 oxygens. So if you add 4 H2O, right? If you add 4 H2O and if you're adding like 8 OH minus, again it will create imbalance because again O is added to the left hand side. Yes or no? Tell me yes or no. Right? So this is something wrong. This is something wrong, right guys? Yes or no? This is something wrong. So what you have to do, think about it, right? Just think about it. Now instead of 4H, yes, instead of 4H2O, now required oxygen, think about it, right? I'm just telling you one simple trick. Required oxygen is 4. Agree? Required oxygen is 4. Required oxygen is 4. Okay? Right? Now if you think about this, if required oxygen is 4, okay, what you have to do? Add, see, wherever there is less oxygen, remember this, which side will have less oxygen? This is, you remember, the side having less oxygen, add what? OH minus. Okay, side having more oxygen, add H2O. Got it? Tell me yes or no. Got it? Now your question should be how much, right? So this twice as deficient. Okay, and H2O same as deficient. Okay, as simple as that. Now think about this. Oxygen is deficient in which side? Reactant side or product side? In this case, tau. Oxygen is deficient in which side? Reactant side or product side? Product side, right? So what we should add? OH minus or H2O? OH minus or H2O? Tell me what we should add. OH minus. How much? How many OH minus? We are having 4 O deficient. So how many OH minus should be added? 8. Very good, Anjali. So 8 OH minus. And this side, how many H2O should be added? This side, how many H2O? Yes, 4 H2O. Now check. Now check. Everything is balanced. Now check. Everything is balanced. See, guys, everything is balanced now. Right? 8 OH minus, check. 12 oxygen. It's actually 16 both sides, check. Right? Okay. Okay. Right? I hope all of you understood. Now let's solve one more in basic medium. Let's solve one more in basic medium. Okay. One more in basic medium. Now I'll just give a small simple reaction. Okay. So the question is, I2 gives I minus plus IO3 minus. Now tell me which type of reaction it is. Guys, which type of reaction it is? Which type of reaction it is, guys? Disproportionation, right? Not decomposition. Disproportionation reaction. Okay, right? Disproportionation reaction. Very good, right? So what you have to do, okay, right? Just check. This I2 is converting into I minus, right? So the charge here was 0. So from 0, it is going to -1. And here, from 0, it is going to what? Tell me, +5. Right? Now tell me, what is the total electron exchanged? Think about it. What is total electron exchanged? Guys, tell me, what is total electron exchanged? Number of total electron exchanged. Losing 5 and gaining 1. Total electron exchange is how much? If you don't get it, you can just write like this. I plus I, okay, right? This you should not do in exam. I'm just telling you for your own sake, okay? If you don't get, right, if I'm not getting the question, then you can just do like this. -1 plus 5, right? Now what you have to do? You have to multiply this by 5. Agree? Yes? Tell me, guys. Or you can just write like this, half I2 plus half I2. Okay? Still, it will be same. Yes or no? Tell me, guys, please respond. It is a disproportionation reaction. I'm telling you how to balance disproportionation reaction. Right? So what can you be done? If you do this, it will be half I2 plus 5 I2 by 2 gives what? Now this is 5 I minus, right? Plus IO3 minus. As simple as that. Agree? Tell me yes or no, guys. Yes or no? Tell me. Got this? Yes or no? Please try to understand and let me know if you got this or not. 1 I2, right? So in order to remove confusion, I split it into half I2 plus half I2. Yes? Now, then 1/2 I2 is losing 1 electron to form I minus, and 1/2 I2 is gaining 5 electrons to become IO3 plus. So obviously, this should be multiplied by 5. So this half I2 should be multiplied by 5, and this is also 5 I minus. Okay, right? So balanced reaction would be what? Add them again. So it is 3 I2 gives 5 I minus plus IO3 minus, right? Now, balanced, tell me yes or no. Then basic medium. Basic medium. number of oxygen, this side 3, this side 0. So this side have less oxygen. So what you have to do, how many oxygen is deficient? 3. So add 6 OH minus this side plus this side plus 3 H2O. Got it? So this is balanced. Balanced, everyone? Tell me yes or no. Guys, are you getting? Raise your hand. If you're getting this for disproportionation reaction, please raise your hand. If you're not getting, please ask. Right? So this is how you balance a disproportionation reaction. Okay, easy enough? Tell me, easy enough? Very good, guys. So this was the balancing of reactions. Okay, I hope all of you understood balancing. Yes. So let's see one more example. See here, this is oxidation. This is oxidation number method, right? So this is your skeletal equation. This is your skeletal equation. Step 1, I'm just saying again step by step, right? Skeletal equation is this. So charge 0, +1, +5, -2. Just write the charges. Step 2. Step 3, right? Step 3, check the charge which is changed. 0 to +2, 0 to +2, and +5 to +5, +5 to +4. So this is not changed, but this has been changed, right? NO2, +5 to +4, right? So we can say that it is increase in oxidation number by 2 and decrease in oxidation number by 1. So this should be multiplied by 2, right? This is multiplied by 2. Okay, got it, right? This is what we do in oxidation number method. Then tell me, balance. Yes, balance the elements. Balance the elements. Okay, so here we can see, nitrogen is not balanced. Nitrogen is not balanced. Okay, and hydrogen is also not balanced. So we'll balance nitrogen, hydrogen, oxygen by normal hit and trial balancing. Okay. Okay. Then I Yeah, so this was the steps of ion electron method. So we have already discussed ion electron method, right? So we have to, the only difference is in ion electron method, we have to balance the half reactions. We have to write half reactions, then balance it, balance the electron, then balance oxygen, right? And hydrogen by adding H2 and OH minus. Okay, sorry, H plus, H2 and H plus. Okay, right? Okay, now next. In alkaline medium. Now, when we talk about alkaline medium, in alkaline medium, we will do the same steps. The only step which will change is addition of OH minus. Okay, so see, in some books, OH minus and H plus will be added first, then electron will be balanced, and in some books, electron will be balanced first, then OH and H plus will be added. Doesn't matter. Frankly, doesn't matter. Okay, you can do any steps. Okay, at any point of time, doesn't matter. Okay, right? Okay, try solving this question, guys. Try solving question number 3. Everyone, please try solving question number 3. Okay, okay, Suhas. It's easy, right? It's easy. Yes, Srihari, very good. So the answer is yes, very good. Nishita, check again, Nishita. So first you have to balance which atoms, right? First you have to balance atoms, then you have to balance electrons. Okay, that's what I did now. C2O4. So balance atom first now. So the answer is B. Guys, the atom is, sorry, the answer is B. First you have to balance carbon. Okay, right? Then you have to balance, right? So the answer is B. So check, let's check. So see this, right? This is C2 and so this is 2. So first 2, mention 2, as simple as that. Now this charge here is +3 and charge here is +4. Okay, right? So one carbon is losing 1 electron. So 2 carbon will lose 2 electron. 2 electron. Okay, got it, right? Now this oxygen, right, is losing how many electrons? Tell me. -2. Okay, this is -2, right? Okay, one oxygen will have charge of -1 because 2 oxygen will have charge of -2, and this one oxygen will charge of -2, right? So this is gaining how many electrons? One oxygen is gaining 1 electron, so 2 oxygen will gain 2 electrons. Okay, got it, right? In this case also, it is -2 only per electrons, and this is -2 only. So this is gaining 2 electrons. Okay, now next hydrogen. If you check hydrogen, okay, this is 2 hydrogen. Now if it is 1, okay, if it is 1, so 2 to 4 hydrogen. Now this should be 2, but we have to balance oxygen first. After carbon, we have to balance oxygen first. So first balance carbon, C2O4 plus XH2O 2 gives 2 CO2. Carbon balance, charge balanced, plus ZH2O. Then balance oxygen, step by step, right? Balance oxygen or hydrogen, you can balance both anyways, doesn't matter. Okay, so hydrogen C, X, 2 plus X, and here Z, right? And oxygen 4, X2, right? So in carbon, you have to balance oxygen. So here we have 4 oxygens, and here we also 4 oxygens, right? But hydrogen have 2, hydrogen we have none. So plus 2 hydrogen, 2 H plus, okay, because you can add H plus in the acidic medium, okay. Then now if you see, electron is also balanced. Electron is also balanced, and here it is H2 is converting into H2O. Hydrogen balanced, oxygen, right? 2 oxygen, 1 oxygen, right? So what we have to do? Tell me what you have to do. Multiply this by 2, right? Multiply this by 2 because oxygen, again, it is ion electron method, na? Step by step ion electron method. So just wait. That's why I told you ion electron method, it's comparatively easier. So it is C2O4 2 minus gives CO2 ion electron method. Forget about this. Let's see this. 2, right? So it is how many electron it is? Tell me, it is +3 and this was +4. So it is gaining 1 electron, losing 1 electron, losing 1 electron. But since 2 molecule we have, sorry, 2 carbon we have, so it is 2 electrons. Now oxygen, 4 oxygen, 4 oxygen, balanced, no issues. Next one is H2O2 is converting into H2O. Okay, so electrons, again, it is -1, it is -2. Okay, so H2O2 plus 2 electron will give you H2O. But again, oxygen is not balanced. So what we have to do, right? 2 H2O. So if you're adding 2 H2O, so oxygen is balanced, but what about hydrogen? Hydrogen is not balanced. So 2H plus. Okay, right? Now right? But in this case, hydrogen was also there, H2 was also there. So in this case also, we have 2H plus in this side because you have to keep hydrogen also, okay, right? You have to balance anyways, hydrogen, yeah, you have to balance. Now add them. If we add them, what we will get? H2C2O4, 2 minus, sorry, H2C2O4 now, plus, now 2H plus 2H plus will get cancelled, 2 electron will get cancelled. Okay, so we are just left with H2O2. Okay, gives, this is 2CO2 plus 2H2. Okay, as simple as that. So that's why I told you to follow ion electron method. Okay, you can do by oxidation number method also if it's feel fine for you, right? Okay. Now, the next concept that we are going to study is equivalent concept. The concept of equivalent. Okay. Now, what is the concept of equivalent? What is the concept of equivalent? So first of all, right, I hope all of you remember mole concept, molecular weight. Yes? Yes or no? Tell me yes or no. I hope all of you remember molecular weight, which is the weight of one mole of any substance. Now think about this. Just think about this. Suppose you have, uh, you have samosas. Just think about it. Samosas and ketchup packets. Okay, just think about this, right? I'm just giving one lame example. Now suppose if in order to eat one samosa, right, in order to eat one samosa, you require 2 ketchup packets, small packets, right? In order to eat one samosa, you require 2 ketchup packets. So can I say that, right? For one equivalent of samosas, we need for 1 gram of, or 1 unit of samosa, we require 2 units of ketchup. Think about it. Can I say that? For 1 unit of samosa, we require 2 units of ketchup? Yes or no? Think about it. Yes? Right? Okay? Everyone is getting this? Yes? Okay. Now think about it. Suppose you require 3 books. Suppose you require 3 books, right? And a friend of yours can give only 1 book, right? Then how many friends do you require? Just think about mole concept only. How many friends do you require? 3 friends, right? Easy, 3 friends, 3 friends, right? Now, can I say that one friend is equivalent to 1 by 3 of you, or, right? U is equivalent to 3 of your friends, okay? I'm just giving some lame example, okay? So the concept of equivalent is something like this, okay, right? It is something like this. So basically, when you talk about moles, it's the number, it's the molecular mass, right? It's number of electrons and all. Equivalent concept is almost same. It is not different. It is almost same. It is just the different way of speaking it. Okay. For example, I can say that 1 mole of Mg react with 2 mole of Cl. Agree to give 1 mole of MgCl2, right? In mole concept, right? Any issues? Tell me. Okay. Now, if I'm saying this like this, 12 gram of Mg, right? 12 gram of Mg will require 35.5 gram of Cl, right? To form some amount of MgCl2. That statement is also correct. That statement is also correct. Yes or no? Tell me. Yes or no? Guys, tell me yes or no. That statement is also correct. Okay. So what is the difference? So if you say, sir, there's no difference, right? You just converted it in terms of mass, right? That's why I said, right, the concept of equivalent and concept of moles can be applied simultaneously in the same problem. It's just how you represent it, okay? Now, when you talk about number of moles, right? When you talk about number of moles, okay, you specifically talk about reactions which are balanced, right? You specifically talk about reaction which is balanced. But when you talk about equivalent weight or concept of equivalent, you don't worry about reactions balanced or not. You just say what amount of one substance is reacting with what amount of other substance. Okay, right? For example, if I can say that here, right? One equivalent of Mg will require with one equivalent of Cl2 to give one equivalent of MgCl2. Okay, right? Got it? Yes or no? Yes or no? Tell me guys, yes or no? Okay, okay. So let's see some more examples. So what is the definition of equivalent weight? So I can say that equivalent weight is the weight of element, right? That will combine or replace directly or indirectly 1 gram of hydrogen, 1 gram of hydrogen, 35.5 gram of chlorine, or 8 gram of oxygen, or 108 gram of Ag. So these are just as a reference because someone has to be taken as reference, right? So these are just as a reference. Okay. For example, when you discuss atomic mass, so it was 1 by 12 mass of carbon. So that was also a reference, right, everyone? That was also a reference. In the same way here, it is the reference, right? The amount of any element that will react with 1 gram of hydrogen or 35.5 gram of chlorine or 8 gram of, tell me, 8 gram of oxygen. Okay, got it, right? Now, if you see this, wait, I'll just, yeah. So if you see this example, so, right, wait, when you talk about moles, so I can say that 1 mole, sorry, my bad, 1 mole react with 1 mole of Cl2 gives 1 mole of MgCl2, right, 1 mole. But when you talk about equivalent, so this is how, what is the weight of this? This is 71 grams. This is 71 grams, right? Right, everyone, Cl2, 71 grams. So tell me, this Mg should be how many equivalent? Because I said that one equivalent which will react with 35.5 grams. So if it is reacting with 21 grams, so it is how many equivalents? Tell me, how many equivalents? Mg should be of how many equivalents? Tell me, guys, Mg should be how many equivalent? If one equivalent will react with 35.5, then how many equivalents will react with 21? Equivalent, just talk about the number, right? One equivalent is reacting with 35.5, then how many equivalent will react with 71? 2, na? As simple as that, right? 2 equivalent. 2 equivalent. Yes or no? Yes or no? Just try to understand the basic definition over here because formula wise it's easy. Don't worry. Formula wise it will be easy. Okay. Right? So this was the conceptual definition, right? Now, when you talk about the definition like molecular weight, so yes, okay, multiplying obviously. So when we talk about, just think about, I'll just make you the comparison. When you talk about equivalent weight, equivalent weight, right? So basically it is your atomic weight thereby something called n factor valency factor or valency factor. Now, if you remember, I have told you what is n factor or valency factor. How many of you remember this? What is n factor or valency factor? We'll continue this in next class, but tell me, how many of you remember valency factor? Right, I have told you it is number of electron lost, shared, or lost, gained, or shared. Gained or shared. Right, everyone? Right? Number of electron lost, gained, or shared. Okay. So we will continue with this. We'll continue with law of chemical equivalence on Friday. Okay. Right, everyone? Okay, everyone? Okay. Thank you, everyone. I hope all of you understood concepts till this point. Yes or no? So please try to solve 9.1 completely. 9.1 completely try to solve. Okay, I'm not giving any other homework. Okay, right? Yes, go through the PDF. Everyone, please go through the PDF. Okay? Okay. Bye, everyone. Take care. Bye, everyone.